Hello FJA students, welcome to another FJA math notebook entry. We are going to today be titling it Similarity of Angles and Triangles. We're just going to be using this sheet of paper here, cut out along the dotted lines, and in fact both of these are the same, so you're only going to need one of them. Let's start by cutting, but just remember you want pencils, maybe some pens around. Today it's going to be nice to have a straight edge to make some nice little drawings, glue, and of course to begin, some scissors for cutting. Now that we have one, let's fold it in half and glue it down on this side and place it right here. At the bottom of the notebook, we're going to make 3 different triangles. I'll make them now. I want you guys to make similar ones. Use a straight edge so they look really nice. All right, so just for reference, this is a side. Triangles have 3 sides. This right here would be an angle. Triangles have 3 angles, that's why it's triangles, tri for 3 angles. And then these two are a good example of congruent shapes. These are congruent shapes, which means shapes that are congruent. Congruent means equal in geometry. So these, even though maybe they're not perfect right now, but congruent shapes mean that they are the same. So finding similarity or congruence for angles and triangles, there are 3 ways we can tell that 2 triangles are the same. Even if they've been rotated and maybe look slightly different, there are 3 criteria. The first one is side, side, side. So what that means, we flip this up here, side, 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 means that all 3 of the sides of the triangle are the exact same length. We also refer to this as SSS. So side, 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 SSS. So let's look at what that means. What I've done is I've drawn 2 triangles. And the way we're going to show that these 2 are the same by side, side, side is we're going to make marks. So this red mark and this red mark, that tells me that those 2 sides are the same. And I'll zoom in here a little bit. That means those 2 sides are the same. Then let's say I've got blue. I'm going to make 2 blue marks here. 2 blue marks there, 2 blue marks here. That means that those 2 sides have the exact same measurement. And then in green, I'll mark this side with 3 and this side with 3, and that means that those sides have the exact same measurement. So again, the definition here is that if 2 triangles have the same measurements for all 3 sides, they are congruent. Let's write that. So this is actually pretty cool. If you really think about it, if we've got 2 triangles that have all 3 sides the same measurement, we don't have to know anything about the degrees of their angles. We don't have to know, right, what the degree of that angle is on that triangle. We don't have to know that. It's good enough to just know that the 3 sides are the same, and just the way triangles are, 2 triangles that have the same side measurements on all 3 sides will guaranteed have the same angles as well. It's actually really, really cool. Cool theorem. So now let's look at the next one, side, angle, side. This is SAS, so I'm going to write this down here, side, angle, side, SAS. And what this tells us is if there are 2 triangles that have one side and another side plus the angle in between, if that's the same, that's all we have to know to prove that that triangle, those 2 triangles are exactly the same. So let's write a little bit of a diagram here. So this is side, angle, side. Side, angle, side. Side, angle, side. So again, let's make 2 triangles here. So I'm going to make So I made 2 triangles here, but they're turned in different ways. And the way that we can tell that these are the same is if one side, these two sides with green are the same, okay? These two sides with that little green mark, they're the same length. Then these two sides with the red mark are also the same length. And then in purple, the angle in between them is also the same. Also the same. So if we know that the side and the angle and then the other side that makes up that angle, if those are the same in two triangles, then we know that those two triangles are congruent. Even if they're turned in different directions, that is all the proof we need to prove that they are congruent, that they are the same triangles. So let's write that definition down. So there's our definition for side, angle, side. If the two sides and the angle they create are the same on two triangles, then the triangles are congruent. Last one we're going to go over is angle, side, angle. Now this tells us that if we've got two triangles and the angle and then the side that connects it with another angle, if those are the same on two triangles, then those triangles are congruent. Let's draw two triangles real quick. Copy after me. All right, so angle, side, angle. So let's say these two angles are the same. If we know that they're the same measurement. And then this angle, this side, so I'm going to make it green. If this side that connects it over there in green to this purple angle here, now if those are the same on two triangles, so this angle and this angle are the same, the purple and the red are the same measurements on two triangles, and then the side that's in between them is the same measurement on those two triangles, then those triangles are congruent. They are the same. Let's write that definition. Angle, side, angle, ASA. So that's our last note. If two angles in the included side are congruent to two angles and the included side in another triangle, the triangles are congruent. So that's all we've got to know in order to know that those triangles are congruent. So I hope this is helpful. These notes are going to help you quite a bit as we keep moving through here. So save them, hold on to them, reread them, make sure they're clear so that you can use them in our quizzes moving forward. Thanks.